What is the amplitude? Yeah, Eleanor. 3. What else is going on with that amplitude or the number in front? Yeah, reflection. Good. Just gonna do that here. Okay. What is the period? Okay. One thing. Yeah. Great. Yep. Pi. Okay. One thing to keep in mind. This number in front, and this is how it's written, where you see the two set of parentheses. You do not want to distribute. Okay. I know we want to do that all the time, but this is the case you do not. All right. So the reason is if we were, then a few things will change. Our phase shift as well as the period would change as well. Okay, so it's always going to be written with your B value outside the set of parentheses, if you're moving left and right. All right, so keep that in mind. The period is still always 2 pi over 2 over that B value. So the period is pi. What is our vertical shift? Got it, great. Thank you. What is our vertical shift? Yeah. Down 6, okay? That is also our what? That is our midline. So, down 6, and that is our midline. So, regarding the amplitude, what can we say? We know it's a reflection, but what else? What other terms can we use for this? What other terms? It is a stretch, okay? So I'm just going to put here. Just again, the terminology is still the same when we describe. The only thing that's different is our amplitude and now vertical shift, okay? Now our phase shift is whatever is in the parentheses, okay? So x plus pi, what direction are you moving in? Left, good. Left, however, now we're moving left radians, okay? So if it is x plus pi, we are moving left. If it is x minus, what direction? Right. Okay. So this is new to us. Okay. We will see how these graphs look. You will not be tested on graphing phase shift, however, identifying phase shift. Yeah. Well, it's a cosine growth, but it's still a vertical shift down. So your midline is changing. So if you were to graph this 1, 2, 3, 4, 5, 6. Here's our midline, right? Still at -6. And then our amplitude is 3. 1, 2, 3. And then 1, 2, 3. We're at -9. So our graph is going to be in between. Okay, so yes, it is a negative cosine graph. We will start at -9, but you're still hitting this midline along the way. Okay, it just moves that whole graph down. All right, any questions on this? Okay, any questions on the homework? I know there was a little typo on number 4 where it was 3 cosine with that negative sign. Don't worry about it. It was not -1 or anything. I crossed it out on the key, so hopefully you saw that. Any questions on the 6.5 practice? Yeah, it's E. Okay, so E is the only difference here is this 2 is out of place. That's it. Okay, so if I was to rewrite, the midline was in the front. And that was a little bit of a challenge to hopefully not subtract those together. Okay. Any other questions from the practice? Okay. The graphs we learned, and we are going to apply them to word problems. Okay. So if we could turn to, I don't even know what page this is. 6.6 was right after the warm-ups yesterday. 10, page 10. Okay. So we're looking at tides. We will be looking at Ferris wheels as well, okay, today. So looking at the tide and the cape can be measured by using the scale on the pier. The highest mark, okay, the tide reached was 22 feet. Okay, so that would be the maximum, right? The lowest mark it reached was 4 feet, which is the minimum. A full cycle of the tides takes 12 hours. So a full cycle would represent what? The period, okay? So the period takes 12 hours, okay, from start to finish. All right. So they gave you the kind of shell of the equation, okay? A cosine pi over 6x plus d. So one thing to keep in mind, a lot of these functions for word problems regarding the Ferris wheel and or tides will most likely be in cosine, okay? And you're going to see why in a second, all right? So the height of the water on the scale can be modeled by this, all right? Now, how we got the pi over 6? Well, if the period is 12 hours and it's 2 pi over b, we haven't seen this yet, 12b equals 2 pi divided by 12, and that's how they got the b value of pi over 6. That's how they got the b value of pi over 6. Okay? So our b value is in radians because we're doing real life, right? We're talking about hours, which is a numerical value. All right? So we're going to sketch a picture. Okay, we're going to sketch a picture. So I want you to draw this L shape as far as you could go. Okay, so we're not going to graph yet. We're going to fill out our x and y axis by what we know. Okay, so one full rotation takes 12 hours, right? So I know I am going to end at 12. Well, on our sine and cosine graphs, we had equal amount of space, right? So what did we do? We divide by 4. So we take 12 divided by 4. What do we get? 3. So we have 3, 3, 6, 9. Okay? 3, 6, 9 is our first values, right? Obviously, it could continue, all right? So 12 hours to make one complete rotation. Well, what else do we know? What else was given to us? Eleanor? The maximum height was 22. What was the lowest? Go ahead. 4. Okay. So we know this represents our height. This is talking about our time. Okay. How do we find our midline? Go ahead, Grant. Excellent. We add 22 plus 4, which is 26 divided by 2, 13. Okay, so 13 would be our midline. Okay, so 13 would be our midline. Right? So how can we fill this out? All right. D is what amount? The value of D? 13. Okay. What would be the value of A? What would be our amplitude? 9. Okay. Because the 22 minus 13, 13 minus 4. The difference between the max and the midline is your amplitude. Does that make sense? Okay. The distance between your maximum and your midline is your amplitude. Okay. So now, consider low tide started at 2 a.m. Okay. So we could adjust we could figure out where 2 a.m. will be. Okay. So, where do you think we should put 2 a.m. as our low tide? Yeah. Yes. Where 0 would be. So consider low tide at 2 a.m. Kate, you are brilliant. Why? Yes. Okay. So this is the key piece of information. That's why I didn't want to create any equation yet until we drew a picture. Okay. Consider low tide to have occurred at 2 a.m. Well, if low tide is 4 feet, was it? 4 feet? Yeah. 4 feet, then our A value must be what? It's talking about A. You remember the cards? The cards were able to give you either positive or negative, right? So the A value would be negative, and we could put right next to it, the amplitude is the positive 9. Okay? So now we're going to fill in our equation. Okay? So we have f of x equals negative 9 cosine pi over 6x plus 13. Okay? So let's graph this thing, one period, okay? So since there's a reflection, 2 a.m. we're at 4. Where's next? What height? 13, then where? Yep, then where? Good, then where? Okay, good. All right, so this is one rotation, okay? So if we had to change these increments to time, just write it right next to it. If this is 2 a.m., this would be what? 5 a.m. At 6, what would we? 8 a.m. Then 11 a.m. And then 2 p.m., right? And we could keep going, can't we? If we wanted to see it, yeah. And we're going to check it out shortly. So, when is the next high tide? When? So you're actually putting a time frame to it. Yeah. Careful. High tide. 8 a.m. Okay. This would be 8 a.m. Now looking at this picture, after 8 a.m., when would be the next high tide? 8 p.m. as well. Kate, how'd you get it, hon? You just add on 12 more hours. Good. Excellent. What times during the day, so now during the day, right, will the water be 13 feet on the scale? Go ahead, Grant. during that day. Sorry. Yep. Excellent. Sorry, I read that wrong. What times during that day? Okay, that's a key word. If it was during the day, it would be 5 and 11. Or maybe 5 p.m. and 11 p.m. Okay, good. What will the height of the waves be at 5 a.m.? Go ahead. 13 feet. Excellent. And it's a different way asking the question we already found out. What will the height of the waves be at 8 p.m.? 8 a.m. Sorry. p.m. p.m. Yeah. Go ahead. 22 feet. Yeah. Well, good. Okay. So, not too bad, right? Not too bad. You could even, if you wanted to, continue this. Sometimes you might have to, but if we did a 24-hour scale, it would be the same rotation over and over again. Yeah. Uh-huh. Most cases, however, there's going to be times where you have to find that B value. You're given the period. Okay. You will always be given some sort of period with it. Okay. Any questions? All right, let's try another one. Okay. Do you guys want to try it on your own? Give it a try. Work with somebody if you want to. Go through number 2. Okay. All right. So it should have been fairly similar, okay, to the one we just did. All right. So we're looking at tide in Fairfield can be measured by using the scale on the pier. The highest mark of the tide reached was 10 feet. The lowest mark was 2 feet. Okay. And again, it's 12 hours. Okay. So we have the lowest mark of 2, highest mark of 10. What is our midline? Yeah. 6. Okay. So our D value is 6. What is our A? Yeah, Jaden. -4. Good. Because they're saying now consider low tide have occurred at 12 a.m. So if this is 12 a.m., that is low tide. Okay. What would be my equation then? Yeah, Catherine. Perfect. Okay, y or f of x, whatever you guys got. Okay, what times during the day will the water be 6 feet on the scale? Jaden, go ahead. Good. Excellent. Okay. What times during the day will the water be 8 feet? Kaden? 4:30 a.m., 4:30 p.m., 7:30 a.m. How did we get that? I divided 10 feet, 6 feet. I added them together, then I divided by 2, and I divided 9 and 12, or 4, 6, and 9. Oh. They added. Okay. Okay. Anybody else? Yeah. Okay. How'd you get it? Oh. Okay. Right, so I want you to look at our scale, 2, 6, and 10, right? So 8 feet would be roughly here, right? So think of our graph right now. And I like how we tried to guess, right? What it would be. How can we find accurately what the times would be? Accurately. Calculator. How? Okay, we could do that. What else? Yeah. Yes, you would. So you would have 8 equals -4 cosine pi over 6 x plus 6. Okay? And I just want to confirm what you guys got. All right? Huh? You have to do y1, y2. y1, y2. All right. Yep. You're welcome. All right. Let's see. Now we should be in radians. Okay? Make sure you go back to radians. Yeah. Mode. Here. I'm going to go through it right now. 8, then -4 cosine. You need 2 sets of parentheses. For second pi over 6. Close that set. X. Close it. Oops. Close it again. Plus 6. Oops. I meant to put this on the other. Hold on. 8, and then enter. -4 cosine. Second, this little caret is where you find the pi. Divide by 6. Close it. X. Close it again. Plus 6. Was it? Okay. All right. I just want to make sure I'm in radians and you guys as well. If you go to the mode, I'm in radians. Are you guys? Because it's pi over 6. So you want to be. I forgot. Do you want to use that one for now? Okay. And then I'll figure this out when we're done. Okay. So we're in radians. Now, the window should be very straightforward. Okay? The window should be 0 and then 12 hours, right? Was the period. 0 to 12, because we don't care about the negative. The scale, we could go by ones if we wanted to. Right? The minimum, we're going to put 0. The maximum was 22. Nope, 10. Kidding. 10. So we could do 10. See what happens. Let's hit graph. Look at that pretty graph. Okay, so how many times do we have to do intersect? Twice. So second, trace, number 5. But right now my cursor is in the middle. I want to move it to the left. Do this one first. I'm going to show you another way as well. Here, so it's close. Hit enter. 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 Until you see the intersection of 4. Yes. Okay. Could be maximum switch. Maybe. Or something. Oh. You have to use negative. Okay. So write down x equals 4. We'll get to that in a second. And then second trace. Number 5. And then move your cursor to the other side. Huh? And 8 was the other one. So you will reach 8 feet on the scale when x equals 4. and when x equals 8. So you guys that did an estimate, you were right there. You're really close. What would be the exact times? 4 a.m. and 8 a.m. And then if we continue, we would have more, right? 4 p.m. and 8 p.m. We could also went to second table to see where it's the same value. Yeah. Yeah, it goes up and then back down. So you have it on the way up and then you have it on the way down. Curves over, yeah. All right. So, what times during the day? Sometimes though, when you guys came up with those little strategies that you just said, that will work. Okay. This is just confirming it in the calculator. Okay. So there's multiple ways. We could have also, say if you said it would be 4:30. Okay. If you did, 4 hours and 30 minutes, okay, converted it, and then plugged it in for X, you could see if you got 8 feet as well, okay? So we could plug in 4 here to see if we get 8 feet. Yeah. This would be a calculator. Word problems will be a calculator. Pretty much the graphing will not be, okay? The non-calculator, all right? Questions? Okay, and again, seeing this here, what times during the day, if you don't see it on the graph and you know it's the y value, y1, y2, okay? All right, let's see what's next. All right, so we're actually going to skip these two for now, okay? 3. We're going to go to our friend, the Ferris wheel. This is where you'll see sign. Okay? We're going to go to where it says Ferris wheel. And this will be it for today, you guys. Okay? It should be at the bottom, I think. As you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. That just means sine and cosine. It's constantly a wave. When the last seat is filled and the Ferris wheel starts, your seat is at the 3 o'clock position. Important information. 3 o'clock position. So where would that be? Zero. It would be at 0 because think of 3 o'clock. Think of a clock, right? Isn't it 12, 1, 2, 3, 3 o'clock? Now apply it to our unit circle. Boom, 0. Where we get on, right? I know, brilliant. All right, let T be the number of seconds that have elapsed since the Ferris wheel started. You find that when you reach the top, you are 43 feet above the ground, and that the Ferris wheel makes 1 revolution every 8 seconds. Pretty quick, okay? The diameter of the wheel is 40 feet. So we have a nice little picture over there. How is it? Is it looking pretty even? Are we good? All right, cool. So, how am I labeling? What's happening? What's going on? Go ahead, John. 43. Okay. 43 is our max. Who could tell me something else? Kate? Why? Correct. So 43 minus 3, or 43 minus 40, which is the diameter of the circle, gives you 3, which is your minimum. Excellent. Go ahead, Eleanor. The period is 8. So what would my increments be? Okay. What else do we need? Go ahead, Catherine. Good. The midline is 23. You divide the period by 4, always. The period makes 1 revolution, 8 seconds. So 8 divided by 4. Okay? Does everyone see how we got 23? Yes, for this. So 43, the diameter is 40. Half of that, the radius, is what? 20. 43 minus 20 43 minus 20 gives you the 23. Yeah. Yep, the amplitude is 20. Okay, so now we know the maximum point, okay, the maximum value is 43 feet. The minimum value is 3 feet. The period is 8 seconds. Okay, the amplitude is 20. The vertical shift, which is our midline, is what? 23. Okay. Before we decide what our equation is, God bless you, where are we starting? We're supposed to start at the 3 o'clock position. Careful. Yeah. 23. Because isn't that the middle? Yeah. So then, think of the graph. If we're starting on the midline, what type of graph do we have? Sine. Let me go here, here. Boop, boop, boop. Okay, yep. The midline, okay. 43 minus 3 is the diameter, 40, right? Okay, so if I was to draw it on a circle, this is 43, this is 3, okay? 43 minus 3 is 40. So from here to here is 40 feet. Halfway is 20. So from here to here is 20. But 43 minus 20 gives you what? 23. And that's our midline. That's our 3 o'clock position. Okay? All right. So we need to write our equation. All right. I equals our amplitude, which is 20. It's not negative this time. Okay. Sine. We'll get to the b value in 1 second. Plus 23. Okay. Did anyone figure out the b value yet? Go ahead, Ryder. 1/4. Let's see. So be careful, because we have 8 equals, you're forgetting something. Ryder, what are you forgetting? One-fourth pi. Thank you. 1/4 pi. Okay. So good job with the 1/4, right? Keep in mind though, and I'm actually really glad that that came up, is because our period is a numerical value. So the b value must be radians. Does that make sense, everybody? Okay. So the b is pi over 4. Okay. That is your equation. Okay. So what is the height when t equals 6? So 6 seconds. What would that be? Great. It's okay. 3 feet. Okay. Now 9, do we see it anywhere? Yeah. Careful, careful, okay? What can we do if we don't see it on our graph? What does 9 represent? X or Y? X, right? So can we plug 9 into this equation to find out what our height is? Yeah. So take 20 sine pi over 4 times 9 plus 23. Okay. Roughly, what do we get if we round to the nearest whole number? Yeah, Riley. 37? Do we get 37 feet? Yeah, good. Excellent. Sure. Absolutely. Okay, so we have 20 sine parentheses, 2 sets, second caret divided by pi over 4 times 9 plus 23. Okay, any questions, you guys? I think we're good for today.